Good afternoon, and today we'll be simulating a few of the concepts we learned in the projectile motions chapter and see if these concepts hold true. First, we'll be trying to see if the mass really does matter in a projectile problem. As you can see, we have a cannonball, and let's say we shoot a tank shell with a mass of 150 kilograms with an initial speed of, let's say, 10 meters a second. When we fire this, you can see that it took 1.3 seconds to hit the floor and reached a height of negative 8.2 meters and a range of 13 meters. When we change the mass to 100, you see that it still gets the same range, same delta x displacement, and it takes the same time for it to reach the same displacement. And as you can see, the mass really does not matter if it's 100 or 150. Heck, we could change it to 13. Make it way lighter than it previously was, and you still get the same time, the same delta x, and everything. But what would happen if we go back to our original 150 kilograms and change the velocity to, say, 30 meters a second? You see that changing the velocity to the initial velocity displaces the object or the projectile far away from where it was displaced at. And you can see that mass really does not matter in a projectile motion problem. Next, we would like to see if time really is independent of the variable of velocity when it comes to how long it will take for it to hit the ground. Now, as you can see, the initial speed we'll put at 35 meters a second, fairly fast. And he shoots, and it takes him 1.3 seconds to hit the ground. Then we will change. Let's have the same mass, same everything, except now with an initial speed of 0 meters per second, really slow. So we're just dropping them straight down. And you have it 1.3 seconds to hit the ground. So it doesn't matter how fast your initial velocity is, both the projectiles will hit the ground at the same time, no matter what the speed is. Now, if we take the height up a little bit and shoot them with the same 0 meters a second, it takes him a longer time to hit the floor, and this makes sense because he is at a higher displacement off the ground, which would take him more time to hit it.